So as you look at these, I hope it starts to become more familiar to you to find those digits that are significant and not. It's these trailing zeros in numbers when the decimal point is to the left of the non-zero digits that usually causes the most confusion for my students. So now we know how to identify a significant digit and how to choose how many digits to write on the paper. So now we need to think about rounding. When we're doing calculations, your calculator gives you a lot of digits. And it's your job to consider how many digits you can really keep, how well you measured. So we often will have to do a calculation and then round. Now, the rules for rounding in the scientific community is kind of weird, and it's different from what you've seen in most books, and it's different than what you've done in any previous math or science classes probably. We do something called round to even. Have you ever heard of that before? A couple people have. So, how many of you were taught if the next digit is less than 5, you round down, and if the next digit is more than 5, you round up? That sounds familiar. So, we start off the same way. If the next digit is less than 5, we round down. If the next digit is greater than 5, round up. But if the next digit is equal to 5, exactly 5, and there are no other non-zero digits past it, we round to even. So, when you look at this, it means that if the number we're going to round is an even number, we leave it, and if it's an odd number, we round up. So, let's look at this one. We're going to round these all to 3 significant figures. So here, the 0 is not significant, so I want to stop in the thousands place. So I have a 5 in the thousands place. I look to the right and the next digit is a 5. But there's 5, there's a 7 after it, so that is more than 5, so I round 0.206. 274.50. I want to stop in the ones place with 3 significant digits. So I look at the next digit, it's a 5, and after it is a 0, so it is exactly 5. Since 4 is an even number, I leave it as 274. Would most of you have thought to round that up to 275? Yeah, that's what's common in math classes in the K-12 system. Why do we do it this way in chemistry? Because if you're rounding up half the time when it's exactly 5 and rounding down, it gives you a better average. That's why. 540,517. Well, if I want 3 digits that are significant, I'm going to have to stop here in the 1000s place. When I look at this, 517 is more than 5, so I write 541,000. Now, I can't just truncate. I have to add placeholder zeros so that I know it's 541,000 and not 541. But those zeros are not significant because they are trailing zeros with no decimal point written in the number. And what this means is that my measurement was only good out to the thousands place. So I can't tell if it's 540,517 or 540,600. I can only measure to the closest 1,000, and it's more than half of that 1,000. Okay, 1,048. Well, I have a 4 here. 8 is greater than 5, so I round up. 1,050. And again, when I round this 4 up to 5, I don't stop there. I don't truncate. I have to put that trailing 0 in to hold place. Question? So here, my leading zeros are not significant, so I'm going to stop where the 7 is. So I write 0.0020. Now, 7 is an odd number, and this is exactly 5, so I round up to 208. Okay, 896.3. 3 is less than 5, so I round down, 896. So most of the rounding is what you've learned all the way through your math education, just that little idiosyncrasy with the rounding to even. So now let's have you go ahead and round these to 3 significant figures.